Hello and welcome to Prescriptive Analytics. We're going to discuss a problem which kind of looks at all the different issues that can come in a network flow problem. This is predominantly a transshipment problem, but we're going to talk about what happens in a transshipment problem when, as the materials flow through the transshipment nodes, that because of processing we end up losing material. There is loss in material. My name is Hari Rajagopalan and I will be the lecturer for this video. So here we have an example of coal bank hollow recycling, and there are two different recycling processes that convert newspaper, mixed paper, white office paper, cardboard into paper pulp. Now, the amount of paper pulp extracted from recyclable material and the cost of extracting pulp differs depending upon the recycling process used. So if you look at this here, we have the four kinds of paper. Here's the cost for process 1, and here's the cost for process 2. And here are the supply side, and here's the yield. So if you had 1 ton of newspaper, that will then give 0.9 tons of pulp, right? Whereas process 2 would give us 0.85. It's cheaper, $1 cheaper, but it gives us less 0.85, right? Similarly, you can see that in mixed paper, you can see that in white off. So two different kinds of processes, different costs and different yield. Now from process 1 and 2, you can then get the pulp source, and then you can convert that into newsprint, packaging paper, or print stock. And again, there you have cost, and then you have yield. And here is the demand. You have demand for 60 tons of newsprint, 40 tons of packaging paper, 50 tons of print stock. Now, if you look at the supply, that's 120, 70 plus 50 plus 30 plus 40. So that's 190 tons. If you look at the demand, that's 150 tons. So you can easily say supply is greater than demand, but you don't know how much the loss is going to actually create. So you really don't know whether supply is more than demand, supply is less than demand, whether supply is equal to demand. So the way we're going to handle this problem is first assume supply is less than demand, run it. If it solves, that's great. But if it doesn't solve and it throws an infeasible solution, especially if then we try supply is less than demand. So let's look at this here. So here is the different supply zones, and here are the costs. And so here we have the transshipment nodes. The two recycling processes are your transshipment nodes, and here you have the yield here. And then again from here are the costs associated from the recycling transshipment nodes. And oops, you get the yield to the demand centers, and this is the entire problem. So your objective function, of course, Xij is the tons moved from node I to node J, and we're going to minimize them with the costs, with the arrows. So each one of those arrows, you plug in the cost there. So now we look at the raw materials, node 1, node 2, node 3, node 4. Since we are assuming supply is greater than demand, they'll all be less than their supply values. Now we look at the recycling node, and you notice here now we're saying whatever is coming in, only 90% of it actually is converted. So it's 0.9x15. Similarly for x25, it's only 80%. 3.5 is going to be 95, and 4.5 is going to be 75. So we put the yield percentages here, and then we subtract it from the outflow. That's equal to 0. You can say greater than or equal to 0, or equal to 0 is fine. So I've changed it to equal to 0. And then your demand nodes are also going to be equal to. However, remember, from the processing centers, there is some yield there. You're going to lose some. So again, you got to multiply it times the yield there, and then equal to the demand. So once you set this up, we can go to our Excel file. So again, once you have this set up, Excel file is easy to set up. And because we have more, I've done it in the vertical way instead of horizontal. All the variables are given here. Your first column is left blank. Here's your objective coefficient. Here's your sum product. And then you start node 1, node 2 each. You go ahead and put the the constraint coefficients right here. So you go ahead and set it all up, and then finally your demand nodes are set up, and you can set them up. Like I said, it's pretty easy and straightforward. I'm not going to show you how to do it. You can take a look at here. I have an alternative setup. You can take a look at it, but if you do it this way, that should fix your problem. So things to remember in a network flow problem: your gains or losses associated with the flows across each arc effectively increase or decrease the available supply. And that, like I said before, you cannot tell if the total supply can meet demand. So assume that it can, run solver. If it doesn't, then try to modify it such that it cannot. So if demand cannot be met, another objective might be to meet as much demand as possible minimum cost, in which case supply nodes will have equal to and demand nodes will have less than. And then here is another option here. You don't have to use this, but you can use it this way.